Hello everyone.
In this video, we are going to solve this Diophantine equation. We have 111 times x plus 15 times y equal to 21. We have to find the value of x and y in integer. So let's go to the solution. To find the value of x and y in integer, first we apply a Euclidean algorithm to find the GCD of 111 and 15. So we have 111, this is equal to 15 times 7 plus 6, and 15 is again equal to 6 times 2 plus 3, and here we have 6 equal to 2 times 3 plus 0. So from here we have 3 as the GCD, and we can write 3 as 15 minus 6 times 2. From here we insert the value of 6 from this equation. This is the value of 6 we have, so it will become 3 equal to 15 minus 6 is 111 minus 15 times 7, and here we have 2. So further simplifying, it will become 3 equal to 15 minus 2 times 111 and minus 15 times 14. Now we take common 15 from these two terms, so it will become 15 times 1 plus 14 is 15, and here we have plus 111 times minus 2, so it will become 3 equal to 15 times 15 plus 111 times minus 2. Now we compare these two equations. Here we have 21, but we have 3. So now to make it equal, we multiply this equation by 7. So it will become 21 equal to 15 times 7 is 105. So it will become 15 times 105. Here we multiplied 7 to this term only, plus 111 times minus 2 times 7 is minus 14. Now comparing these two equations, we get, here we have same 21 on both sides and 15 here, and this will become y, and this is the second term, this one, so it will become x. So we get one solution, that y equal to 105 and x equal to minus 14, and both are in integers.
Thanks for watching.